Okay, so starting with the wiring, if we look at our diagram here from the manual, I've added some color codes to match my physical wiring here, which I'll show in just a second. We're going to take the positive of the loop power supply. In this case, we're using an Endress Hauser loop power supply. By loop power supply, we mean that it is current limited, so it will not allow more than 30 milliamps to flow through the circuit, which protects any loop power devices in that loop from getting damaged. A 5 amp power supply that is not current limited will definitely cause damage if there's no transmitter to control the current. So this transmitter allows only a limited amount of current to flow in that circuit, typically between 4 and 20 milliamps. But again, we're going to start up here at the loop power supply, and we're going to take our positive and go straight into the positive terminal of the RIA14, and then we're going to take the negative of that loop power supply and go into terminal 1. Okay, then we're going to take the positive of our transmitter, in this case I'm just using a simple temperature transmitter. We're actually going to take that into the negative of the RIA14, and then the negative of our transmitter goes also up to terminal 1. So notice our two negatives are actually tied together into that same terminal. Okay, so that is what we need to accomplish. So let's take a look at our physical setup here. So this is our loop power supply. It's a Endress Hauser product, RIA14. Basically the terminals up here on the top are pre-wired and are routed to these two terminals here, and then that's just simply controlled by a switch. That's just a nice little bench test setup that we have here in the office. If you notice, I have my black wire here connected to my positive terminal, and then I have my white wire or gray wire going to my negative terminal. And that matches my setup up here. Black wire on positive, gray or white wire on the negative. Okay? If we follow those wires into the RIA14, we have a black wire coming into positive and a gray wire going into the number 1 terminal. Number 1 is right there if you can see it. Yep. Okay, so then those two wires are complete. You'll notice that our red coming from our temperature transmitter, this is the positive from the transmitter, is coming into the negative of the RIA. And then the yellow, which is the negative from our temperature transmitter, is coming also into that 1 terminal with the gray wire from the power supply. So then this is what it looks like at the temperature transmitter. The red, as you can see, is going into the positive, and then our yellow is going into the negative. Okay, and so notice that we also don't have any power while we're wiring this up. There was really no safety issue or any potential for damage in this situation. 1, because power is off, and 2, because we're using a loop power supply. Again, that limits the current flow through the loop at a maximum of 30 milliamps. So a 5 amp power supply does not have the same safety capabilities as this device. You can still use a larger power supply, but it's paramount that you have that power supply off while you're completing the wiring, and this entire wiring needs to be set up. This creates a complete loop with your transmitter, which is going to limit the current flow. If you have a large non-current limited power supply hooked just directly up to this RIA14 and no transmitter to limit the current, you will blow the resistors on the back of the main electronics, which is going to look like this, which was returned to us. So some obvious damage, and that is just from no current being limited. Those resistors are there to basically prevent further damage to other components in the event of a high current event. Okay, so this is a functional set of electronics, and you can see those resistors there are actually intact and not damaged. So this is what we're going to use for this test. So next step is just to slide that in, and you have to finesse and be careful with the multi-pin connection on the back side. It's really a feel. Do not force anything. If you don't have it lined up, make minor adjustments and finesse it in there. Once it is lined up, you will feel it slide into place. Okay. And then this is our display connector right here. We take that, and on the back side of the display module, the back side, you'll see this connector. And this connector is where we hook up this ribbon cable. This is going to require 2 hands here, so give me one moment. This is also something you want to be careful with. Make sure you have it lined up, but once it's there, just a gentle push will get you connected, and it'll be obvious. Okay, once that's done, you can seat that down. The best way to do this is this section of the display module lines up with this little line on the main electronics here. Okay, so this lines up with this, and there's 4 of those around the side of the main electronics. So from any orientation, you can see where that's supposed to go. Once that's kind of lined up, you can feel it start to sit, and you just to give it a straight push down. Also, you got to be careful with that because the pins can get bent if you are not careful with that. Okay, and the last thing I'm going to do is take our display module for the temperature transmitter. It has a little 4-pin connector that's going to go right into this port on the transmitter. Okay, now that's connected. Here's our full complete setup, minus the lid for the RIA14. Now if we turn on power, you will see everything start to turn on. You can see the LED right here starting to turn on. The display turns on this, and our display on the temperature transmitter is going. We'll let everything boot up. This device has a display as well, and it is set up right now just to show what the 4 to 20 milliamp value is. So 7.57 milliamps, 7.58. It's going to hover around a little bit, and we're showing the same value here on the RIA14. So we know that this is showing the same current flow as this device. They both agree with each other. And then the display here shows 72.3 degrees Fahrenheit is the temperature. And this is scaled 4 milliamps is 32 degrees Fahrenheit, 20 milliamps is 212 degrees Fahrenheit. So that gives us that 7.6 or so milliamp output if you go through and do the math. If we grab onto the tip of the RTD, we'll see that temperature go up. There will be somewhat of a delay in that response, just with this thick of an RTD. Okay, you see that climbing. If I let go of that, we'll let that go. And you see our current has been updated on both devices. Now, if we want to change the scaling to match, what I would do is I would lift my display module up, and I did not screw down the main electronics, so they are lifting a little bit as I'm removing the display. You normally would not have this issue, but give me 1 second, I will remove that. Okay, so now with the display module just detached, we actually expose that there are some push buttons back here. If I hold on to that E button for a few seconds, the menu will come up. It says menu input. I'm going to go into that menu by pressing the E button. It's going to ask me the curve. The curve is going to be fine, but if I hit the plus button, it'll show me those options. So linear is actually linear, which is what you're going to want for most scenarios. There's also a square root function. I'm going to hit the negative or the minus button to go back to my linear selection. That means it's a linear relationship between 4 and 20 milliamps. Hit the E button, apply any dampening. We are not going to have any dampening, so we'll leave that at 0. And we're moving forward through this menu by hitting the E button. DIDP is basically wanting us to select how many decimal places we want present on the screen. So if I hit the plus button, right now it's set to 2 decimals. I can hit the minus and that'll change to 1, or I can hit the plus button to change that to however many I want to display. You are limited to about, I believe, 4 spaces on the screen. So a max of 3 decimal places. So I'm going to change this back to 2 decimal places and hit E to execute that. DI low is the 4 milliamp value, what I want that to be set to. So right now, just because I want the screen to show what 4 milliamps is and what 20 milliamps is, it's basically just showing me what current is flowing through. There essentially is no scaling. What I'm going to do instead is apply the scaling of the temperature transmitter. That way we can match that measurement. So to do that, I'll just hold down the plus button and it'll start to scroll up. It'll go faster and faster as you continue to hold it. Okay, so I definitely overshot that. That's not uncommon, but you're just gonna, takes a little bit of finagling. I'm going again for 32 degrees Fahrenheit. Definitely have to have a touch for it. .32. Okay, when I'm done, I hit the enter button. Now I'm on DI high. Again, because I originally had it, my scaling just to mirror the 4 to 20 milliamp value. My high value is 20. I'm going to change that by hitting the plus button. And again, the high value of my temperature transmitter is 212. So this one I'm going to hold on for a little bit here, and it's going to climb quickly. And we'll let go. And we'll reinitiate that. Climb up quicker and quicker. And got pretty close. 211 and 12, went a little bit over, so minus to go down. Okay, and we're there. Offset, we don't need an offset because we have an accurate measurement and accurate communication. Display, we can go into that menu as well. DIM is going to be our dimensions, which is basically what units you want to use. In this case, I want to use text. I just want to type in what units I'm using, so I'll hit the E button on text. Okay, and then my text is going to be, this is in Fahrenheit, so I'm just going to put an F. Okay. You can see the cursor move across the screen as I hit the E button. All I need is that one F, and now I'm done. So to exit the menu, I'm going to hit the minus and plus button together. Takes a little bit of finesse. So we basically told it to save, and now it's powering off, and it's going to power back on with those new settings. And now if we take a look at our measurement here on the temperature transmitter, 73.6, and with our setup here, if you look over here, our measurement actually is updating, 73.6. We're at 2 decimal places here, so you can see a little bit higher resolution of that measurement. Let's go ahead and do our RTD test again, grabbing the end of the RTD. Our measurement is going to start climbing up. 75, 76, 77. That kind of stabilized there. 78.7 or so, 78. Yeah, we'll call it 78.7. 78.7 if you round up. So they're going down together. And that's basically it.